Visible, right? Everyone?
Yes, sir.
Yes. So we discussed many things in the last class. Let's revise those things one by one and then we'll move forward. Okay. So in the last class, we were discussing about what is a set, actually, basic definition of set. Then we discussed uh, to write any set in the form of roster form or set builder form. Then we discussed cardinality, right? Cardinality was number of elements in any particular set. Then we discussed about universal set, which will be the biggest set in the question. Yes, which will be including all sets which will be given in the question. Then finite or infinite set. Finite set was where the number of elements are fixed. Yes, we can count that. And then infinite set where we cannot count the number of elements, right? Then null set where if there is no element in the set, then it is called null set. Then we call it empty set also, word set also, zero set also. We represent it by empty bracket or phi. Then we discussed what is subset. Subset was nothing but uh, a set which comprises of each and every element of the other given set. Yes, here the set A is subset of B. Yes. Then superset. Superset is nothing but the bigger set which will be comprises of other elements of the set. Yes. Then we discussed about proper subset. Proper subset means there should be some elements uh, which subset will not be having. Okay, like A is a set where A is 1 2 3 4 and B is 1 2 3 4 7 8. So this A is proper subset of B, right? Suppose if A and B both have same number of elements and same elements, then A will be subset of B, but it will not be a proper subset, right? Then we also discuss singleton set. Singleton set means any set which will comprise only one element. Power set. Power set is nothing but a set comprising of all the subsets of any uh, given set, right? And the number of elements in the power set will be 2 to the power n, where n is the number of elements in any given set, right? Then we discussed equal sets. Two sets will be equal if they have the same elements, same value of elements, right? And the order doesn't matter in any particular set. We can also say it like this, that if two sets are equal, then A will be subset of B and B will be subset of A. Yes. Then disjoint set. Any two sets will be called as disjoint if we don't have any element common. Like intersection B is phi, then A and B will be called disjoint set. We also discussed complement of a set. We denote complement of any set by C over A bar or A dash. Okay. And to find out the complement of any particular set, you have to subtract that set from the universal set, right? Then we were discussing some operations on the set. We discussed union. How do we combine all the elements of any two given sets? We discussed about the intersection part, intersection in which we will take common elements of two sets and we denote this intersection by inverse U. Yes. And we also discussed set difference. Set difference means what? If we are subtracting A from B, so we'll write the elements of B which is not present in A. If we are subtracting B from A, if we are writing A minus B, so we'll write the elements of A which will not be available in B, right? We also discussed about the symmetric difference. Symmetric difference is nothing but the union of A minus B and B minus A, right? Then we were discussing about the Cartesian product. Suppose we are multiplying two sets, right? We are doing the Cartesian product of two sets. So we'll make combination of the sets. Yes. Suppose A is having two elements, 1 and 2, B is having X, Y, Z. So we'll make the we will make the combination with these two elements of A with these three elements of B. Yes. And total 6 arrangements will be made. Then we discussed about some set identities and we were discussing Venn diagram. I also explained you what is Venn diagram. any universal set is represented by the rectangular box, set A and B that is represented by the circles. The common portion of A and B will be represented as A intersection B. The whole sum portion of this, okay, this complete boundary, this complete thing will be called as A union B, right? Set complements. So suppose we want to find out what is A complement. So A complement is nothing but entire portion of universal set except A. Yes. And then we were discussing these formulas, right? I had already explained you this formula and told you to remember this formula. So till here, any doubt? Anyone? Till here, anyone is having any doubt?
No, sir.
Okay. Okay. So let's move forward. Let's talk about the next thing, that is operator precedence rules. Yes, operator precedence rules means what? Suppose sometimes things will be given to you like complicated wise, like suppose it's been given to you A union B intersection C union C complement or something like that. Okay. So if we want to find out, if we simplify this whole thing, what will be the answer? Okay, so I always recommend each and everyone to solve such questions with the help of Venn diagram. With the help of Venn diagram, each and every question will get very easy to you. Okay, but also you can remember some small points, and with the help of these points, you'll be able to find out. You will be able to solve this very quickly. Okay, so always remember first thing first, that we will always solve from left to right. Okay, whatever expression is given to us, we'll always solve from left to right. Second thing is that if we have some parenthesis, if something is given in the brackets, we'll solve that thing first. Okay. Third thing is, after that, we will solve all the complementations. Okay. Whatever is given like A complement or B complement, we'll solve that next. After that, we'll solve the intersection portion. Then we'll solve the unions portion. Okay. And when we'll solve the question, we'll see all these things. And that time it will be easy to you. Okay. Suppose, for example, it has been given to you A union B intersection C complement. Okay. So first of all, what you will do, you'll solve C complement. You will find out what is the complement of C. And then you will do intersection of C complement with B, and whatever answer you are getting, okay, you'll solve this first, and whatever answer you are getting, you will combine this with A. Okay, so we'll apply this parenthesis like this. Okay, now propositions. So we have discussed this while we were doing the theory part. Let's discuss this again. If two sets are equal, then always and always it will happen that A will be subset of B and B will be subset of A. Although we can also say like this, if A is subset of B and B is subset of A, then for sure A and B both will be equal. Okay. Now let's talk about De Morgan's law. S union T complement. Okay. There's nothing but S complement intersection T complement. Okay. So let's draw a universal set. Okay. Let's create S and T. Okay. This is S, this is T. Okay. Now, if I talk about S union T complement, okay. So this portion is nothing but what? S union T, right? This is nothing but S union T. So if I'm talking about S union T complement, so S union T complement means what? Which portion I have to take? The outer portion, right? This outer portion will be nothing but S union T complement. Yes or no? Yes, right? Now, suppose if I want to draw the right hand side portion, okay. So what I can do, again, I have to draw S and T. Yes, this is S, this is T. Now it's saying S complement and T complement intersection, right? So what will be S complement? What will be S complement? S complement is nothing but any portion which is outside this S, which is outside the boundary of this S, that will be S complement, right? This is S complement, outside S boundary. Now, let's talk about T complement. So T complement is nothing but whatever you have outside of this T. Whatever you have outside of this T. Now, if I talk about S complement intersection T complement, it means you have to take out that portion which is outside of the boundary of S and T both. Yes. So you have to take that portion which is outside the boundary of S and T both. Yes. So we'll get the same thing which we are getting from here, right? Yes. So that's why S union T complement is nothing but S complement intersection T complement. Any doubts? Anyone? Any doubts?
No, sir.
I believe no, right? Yes. Okay. Let's
No,
talk
sir.
about this. Let's talk about the second theorem of De Morgan's law. It's saying S intersection T complement. So if I'm talking about S intersection T complement, what will happen? This is S, this is T. Yes. And this is the common portion. Yes. So this is the common portion. This is S intersection T. Okay. Now we are talking about S intersection T complement. So what portion I have to take? Whatever is outside of this complement portion. Yes. Except this thing, whatever is outside that I have to take. Yes. What I can do it for this portion for right hand side, if I want to depict the same thing using Venn diagram. So see, S complement union T complement. So S complement is what? Whatever is outside of S, right? Now T complement is what? Whatever we have outside of T, right? So if we are making the union of it, means I have to take everything except this particular portion, except this particular intersection portion, right? And we were getting the same thing from the left hand side also. Yes. So that's how these two are equal. Okay. You can remember it. Okay. And these questions can be asked directly in the form of MCQs. Okay. Okay. Now let's start our practice questions. I believe everybody is ready with the practice, like pen and paper, right? Yes. Nikhil, Pratesh, Vishesh.
Yes, sir.
Okay. So this is the first question. Let A and B the sets of all positive divisors of 400 and 1000 respectively, including 1 and the number. Then is equal to there is some mistake actually. Let X and Y. There is something missing. Let X and Y. Okay. Let X and Y be the sets of all positive divisors of 400 and 1000 respectively, including 1 and the number. Then number of elements in X intersection Y is. You have to tell what is X intersection Y. Okay. Number of elements in X intersection Y. What should be the approach actually? What should be the approach?
First, finding all the elements of x and y.
Okay. Can you tell how many divisors this 400 will be having?
So we can first do prime factorization.
Even
Uh,
even if you will do the prime factorization to count the number of devices, that would be difficult. Okay. Okay.
okay.
Tell me what is the prime factorization of this 400?
One,
Do you need pen and paper to solve such question? Do you need pen and paper? Generally people do, right? See, we
yeah,
can prime factorize it orally. This is nothing but 4 into 100, right? Yes, and 4 is nothing but 2 square, and 100 is nothing but what? 2 square into 5 square, right? If we have 100, that is nothing but 2 square into 5 square. If we have 1000, so that is nothing but 2 cube into 5 cube. Okay, so the prime factorize is 2 to the power 4 into 5 square. Yes, so can I know what is the number of devices now? By just looking at the prime factorization of this?
Yes.
15.
15. Yes. We will add 1 to it. We will add 1 to it. So that will be nothing but 5 into 3. That is 15, right? Now, if I talk about 1000, yes. So the number of devices will be what? There is nothing but 2 cube into 5 cube, right? So the number of devices will be 4 into 4. That is 16. Yes. So suppose I have to find out total number of devices, that is 15, and number of devices, that is 16, and then we will talk about what is common in between them. It will take a lot of time, right? Yes.
Yes.
So
Yes.
instead of doing this, what we can do, we can just find out what is
HCF.
that number which is going to divide this number and this number both. Because we have to find out x intersection y. X intersection y means what? We have to choose those devices which is dividing 400 and 1000 both. Yes. So what is that biggest number which divides both the given numbers? What do we call it?
HCF.
SCF, right? So what will be the SCF of 400 and 1000?
200.
Yes. So SCF will be nothing but 200. So instead of finding the devices of 400 and 1000, we can directly find out the devices of 200. Understood? Understood?
Yeah.
So the devices of 200 will be what? 1. Yes. Then, and instead of calculating like this 1, 2, 3, 4, you can go reverse. You can go in the reverse direction. How? To find out the devices, just divide this 200 by 1. If you'll divide this 200 by 1, you will be getting nothing but 200, right? Then divided by 2, so that will be 100. Then divided by 3, it will not be divisible. Then by 4, it will be what? 50. Then 6, it will not be divisible. Then 7, no. Then by 8, that is 25. Then by 9, no. By 10, it will be 20. Then by 11, no. By 12, no. By 13, 14, 15, 16, no. Then by which number we are going to divide? Anyone?
Then we go back to 10 again.
Yes. So we'll divide. One second. One second. Yes. So we divided by 8, then 10, and then we can divide it by 20. If we divide it by 20, we'll be getting what? 10, right? And then by 25, so it will be 8, then by 50, so this will be 4, then by 100, so this will be 2, and then I believe by 200, so that will be 1. Yes. So the number of total devices will be,
So you missed 5.
sorry? Yes, I
You
missed 5.
5
Yes, I missed 5, and I also missed what?
and 40.
And
40.
40. Yes. So the total number of devices will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So the total number of devices will be 12. Right? Any doubts here?
So, sir, here we can just take the HCF and then find number of factors of the HCF. That will also work.
Yes, yes, yes. We can also do that. Yes. So we can factorize 200. So this will be nothing but 2 into 100. So 2 and 100 is nothing but 2 square into 5 square. That is 2 cube into 5 square. So the power will be 4, and here the power will be 3. So 4 3 is 12. Yes. Okay. Okay. So let's move to the next question. It's given that number of elements in A intersection B is 10. Number of elements in B intersection C is 20. Now it's talking about number of elements in A intersection A intersection C, that is 30. Then the greatest possible value of A intersection B intersection C is
10.
10, right? We need the number of elements which should be common to A, B, and C, all three of them, right? So there are 10 elements which is common to A, B. There are 20 elements which are common to B and C, and there are 30 elements which are common to A and C. So max to max, which can be common to all of them, will be 10 only, right? Yes, because more than 10 we cannot take, because only 10 elements are given which is common to A and B both, right? Yes or no? Yes? Okay.
Yes, sir.
Let's talk about the next question. That is, if A is subset of B, right? So B union A will be equals to
B.
B. For sure. Can anyone explain why it is B?
Because B is a subset of A, so it might not have all the elements. So A is the answer.
Yes.
मतलब A as the said B option.
A is the subset of B, right? So which one is the bigger, A or B?
A is bigger, so B option is correct. Okay.
No. If A is subset of B, which set is bigger, A or B?
A.
No. B is bigger,
A
right?
is
Because
subset
A
of,
is the
sorry, B,
subset of B.
Yeah, B, sorry.
Yes.
Okay.
So B will be the bigger one, and A might be equals to A. A might be equals to B, or it can be inside of B, right? So anyhow, if you will make the union of it, what you will get? B ultimately, right? Understood? Yes or no?
Understood.
Okay. So it should be C option, that is B. Anyone, any doubts in this particular question? No, I believe. Okay. Let's move forward. We have next question. That is A is goes to 1, 2, 3, 4, B is 2, 4, 6. Then the number of sets C such that A intersection B is subset of C, and that is subset of A union B. So first of all, what is A intersection B? A intersection B is
2, 4, 2, 4.
2, 4. Right. What is A union B?
1, 2, 3, 4, 6.
1, 2, 3, 4, 6. Now we need a set C which will be bigger than or equals to A intersection B, right?
Yeah.
Yes.
Yeah.
And it should be less than or equals to 1, 2, 3, 4, 6. Yes.
Yeah.
So how many sets are possible here?
4C2 plus 4C3 plus 4C4. No, 4, 5. 5C2. 5C2 plus maybe I am wrong.
Okay. Anyone else? Anyone else?
1 plus 3, so 2 and 4 will be fixed. So
8.
1 plus 3C1 plus 3C2 plus 3C3. I don't know the numerical answer.
8.
It should be 8, right? Okay. So let's see how we can solve this. So first of all, this 2 comma 4, this will be equals to C, right? C can be taken as 2 comma 4, right? No issue. Yes. So one answer is this only. Now let's talk about the second type of answer in which we can have any other element, any one extra element. And that one extra element can be what? Either 1 or 3 or 6. So it can be any one element out of these three. So that will be 3C1. And even if you don't know what is C1 or whatever, you can think like this. It can be 1 or 3 or 6. So you have three options, right? Now, except 2 and 4, we can have two extra elements. So out of these three elements, 1, 3, and 6, you can have any two elements, that is 3C2. And 3C2 is nothing but 2 itself, right? Or 3 itself. What is 3C2? 3, right? And how do we calculate 3C2? To calculate 3C2, we can subtract it from this. 3C2 is nothing but equals to 3C1, and 3C1 is nothing equals to 3. Yes, so 3C2 is also what? 3. Now, fourth type of set can be, we can have 2, 4, and all extra 3 elements all together. So that will be this set itself, 1, 2, 3, 4, 6. Yes, so this is 1, this is 3, and this is 1. So total 8 sets possible. C can be any of these 8 sets. Anyone who's having any doubt in this particular solution? Any question in this question?
Sir, what if we approach it a little differently?
Yes, tell me.
So I need to have 2 and 4 in C for sure.
Yes,
Then, so I'm fixing those. Then if I exclude 2 and 4, in A union B, I have 3 elements left, 1, 3, and 6.
yes.
So if I approach it this way, either I take any of 1, 3, and 6, or I don't take any of them. So for each element, I get 2 cases. I do 2 cube, that's 8.
Yes, yes, yes. That is also possible. You have to choose either 1, 3, or 6. It can be taken or cannot be taken, right? So for
Yeah.
1, you will be having two options. You will select 1 or you will not select 1. That is 2 options. For this also you have 2 options. For this also you have 2 options. So that will be nothing but 2 cube, and 2 cube is 8. Yes, absolutely correct. Yes. Okay, now let's move to the next question. It's given as x is equals to 4 to the power n minus 3n minus 1, and y is equals to 9 times of n minus 1. And in both the cases, n belongs to the natural number. We need to find out what is x union y. Try to solve this particular question.
X union Y is Y.
Sorry.
X union Y is Y. Y.
X in y is y.
Yeah, X union Y is Y.
Okay. What about others? What approach did you follow here?
So I found the first three elements of X, which are 0, 9, and 54.
It was 0, 9,
54.
54. Yes. Okay.
While for Y, it will be 0, 9, 18.
And so
So
on.
the table of
Right?
9, table of 9.
Yes.
So
These all
that,
are multiple of 9, and this is also multiple of 9, right? But this is some multiples of 9, and this is all multiples of 9, right? Yes. That's why when you made the union x union y, you will get only y. The complete answer will be y itself. Why? Because this x is nothing but subset of y. Yes, x is nothing but subset of y. And if we make union of any subset with its set, we always get the set, right? That's why the answer will be Y. Anyone who's having any doubt in this particular question? No, I believe. Okay. Let's have this particular question. We have a set A, x comma y, where y is equals to given 4 by x cannot be equals to 0. That is but obvious, because if we put x is equals to 0, this will be not defined, right? So there is another set B in which x square plus y square is equals to 8. Now it's asking you if A intersection B and A intersection B will be 5, or A intersection B will contain only 1 point or 2 point or 4 points.
Option C.
Option C, that is 2 points only. Okay. What about others?
Same for me.
Okay. How did you solve this?
For me, I just put the factors of 4. It's 1, 2, and 4. So divide it with -1 plus 1, because we have the square in the second set. So -1 plus 1, -2 plus 2, and -4 plus 4. And in the second set, B set, we can take only 2 square. So considering +2 and -2. So we acquired with 2 sets with x is -1 or +1, or -2 or +2, or y is -2 or +2.
Okay, that's nice. Any other approach? Anyone with different approach? Okay. So yes, this can be followed, or either you can solve this equation as well, right? That is also you have an option, right? You can also put the value of y, that is 4 by x, into this particular equation, and you can solve this particular equation for x. You will get 2 values of x, and for the same you will get 2 values of y, right? So the answer will be yes, it will